Hello all, welcome. Today we are going to see data structure lab. It means what are the programs that you need to execute or understand for the next 4 months, that is in second semester. And this is prescribed programs for the Bangalore University students. Okay. Now coming to a note, what note says all the programs for all the programs, you need to write a output, flowchart, and the number of basic operations performed. This is important in data structure because whenever you are executing a program, whenever you have got an algorithm, you need to know how efficient that particular algorithm is. So whenever we are executing it, we'll be seeing that how it will be written. Now coming to the first program. First program is about searching a element using binary and linear search. Okay, this will help you understand how efficient are the searching algorithms and which one is better among binary and linear search. Okay, obviously binary search is much more efficient than the linear search, that you will know. Now coming to the next one, that is write a program to sort list of n numbers using bubble sort algorithm. See, we are going to implement bubble sort. In the last sem, you might have studied what is bubble sort, but this sem, we are going to implement it. How you will be running a program or how you will be coding the particular algorithm. Okay. And coming to the third program, which is the same sorting algorithm, we'll be using two more sorting algorithms here, that is insertion sort and the selection sort. And this is just an example array which we can use and display the output in decreasing order. Got it? Now coming to the next program. Write a program to insert elements 61, 16, 8, 27 into singly linked list. If you look at this program, this is related to linked list, and linked list are one of the most important concept in the whole data structure. Okay, and here we need to perform some of the operations on the linked list, like deleting some of the elements, and after deleting or doing some operations, we need to show the list that we have after every operation. Okay, coming to the fifth one, write a program to insert elements into linear queue. See, this program is related to queues, and delete three elements from the list. Display your list after each insertion and deletion. This is going to be common when we are learning programs. We'll be showing you how you'll be able to do this. Coming to the next one, write a program to simulate the working of the circular queue. This is also queue related program, and we are going to simulate it or build it using array. Circular queue is a different concept and array is a different concept. We are going to simulate this queue using array. And then coming to the next one, write a program to insert elements into the ordered singly linked list. Ordered means it will be in some order, like increasing, decreasing order, or ascending, descending, both are same. But in some order, singly linked list will be having, and we need to perform some of the operations like deleting some of the elements and displaying your list after each insertion and deletion. And now coming to the very classic example of the data structure, that is Tower of Hanai problem using recursion. This is a stack concept and you will be learning it here. You will be having, I think you have got around 3, 4, 5 programs on stack. Okay, you can see this. Write a recursive program to find GCD of three numbers. This is the greatest common divisor, Write a program to demonstrate working of stack using linked list. See, working of stack, and we are going to use linked list for implementing stack, right? Coming to the 11th question, write a program to convert an infix expression to postfix expression. When you are learning the concept, you will know what is an infix expression and a postfix expression. And now coming to the next program, that is evaluate a postfix expression. Because yesterday, like in the last video, I have told you that you cannot, the system cannot understand BODMAS rule. Because of that, to evaluate this particular expression, you should use postfix or infix expression to solve it, because system do not understand brackets. Okay, write a program to create a binary tree with the elements. We are going to have binary tree. This is a tree related concept. Okay, and we are going to implement it. After creation, we are going to insert two elements into tree and delete some element from the tree and display tree in each insertion and deletion operation. Okay, write a program to create binary search tree. Again the same thing, and perform in order, pre-order and post-order traversal. This is specially for traversal purpose. Now coming to the 15th one, total we have got 18 programs. Okay, write a program to sort the following element using heap sort. This is also one of the sorting algorithm, and we'll be using one example to sort. And then coming to the 16th one, we have got s1 s2, and we need to find the length of s1. This is basically a program of strings. Okay, concatenate s1 and s2, already you might have done it, but once again we'll be doing it. Extract the substring low from s1. This is a substring, we need to extract it. Find r in s2 and replace it with is. Okay, here r, we need to replace it with is. All these things should be done programmatically. Okay, these are just string operations, we'll be learning that also. Write a program to implement adjacent matrix of a graph. You see, you should know what are graphs. Already you have studied in discrete structures, and this time you are going to implement it in programming. Okay, now coming to the next one, write a program to insert or retrieve an entry into hash from a hash table with a open addressing using linear probing. Okay, this is the last unit of your syllabus, and we'll be learning this, the last unit. See, whenever you are learning this, you need to understand the theory as well, and for that purpose what I have done, I have divided all these programs on the weekly basis. Whenever you learn a particular concept, you are going to implement that one. Okay, now I'll show you. You see, week 1, February 3 to February 9. Yeah, we are going for introduction of data structure, so we'll be mostly focusing on PST related concepts for the week 1, because refreshing all the knowledge of problem solving technique is most important. You need to know the syntax of each and everything that we have used in the last sem, so that it will be easier when you are executing data structure problems. And on the second week, we'll be learning some of the things like mathematical notation, complexity analysis. At that time, we'll be executing one program, and that is, already you know, I have explained on the top. It is searching an element using binary search and linear search. And on the next week, we'll be learning strings, and so we'll be executing this particular program, which is actually listed here on at 16th, but we'll be learning, because we'll be learning strings in the class. Okay, and now coming to arrays. When you are learning arrays in the class, we'll be learning two programs in that week. that is bubble sort algorithm, and then selection sort, and then insertion sort. Obviously you have studied this in the last sem, but whenever you are implementing, understanding syntax is also very important. Now coming to the next one, that is you'll be learning matrices, searching, sorting in arrays in the class, and at the same time you'll be learning heap sort algorithm, and this is just an example array. Okay, now coming to the next one, singly linked list. We'll be learning linked list concept in the class. At the same time we'll be implementing the singly linked list example, and we'll be doing operation on the list. Okay, and then doubly linked list, ordered list. At that time you'll be doing ordered list program in the lab. And then coming to the next week, here we'll be studying stacks, arrays, linked list representation. At that time you will be doing these three things. That is, you'll be demonstrating working of stack using linked list. You see already we have studied linked list in the previous unit, and that's why you'll be able to implement stack using linked list. Convert an infix expression to postfix expression, and then evaluate the postfix expression, this one. Okay, and now coming to the next week, we'll be learning queues, linear and circular both, and at the same time we'll be executing these two queue related programs in the lab. And now coming to the next part, that is you'll be learning trees in the class from April 7 to April 13. And remember, this is just a rough plan of mine to teach you data structures, and there may be some variations when we are learning because of various other factors. This is going to be an ideal plan, but we'll see whether we can implement it correctly or not. Create a binary tree with elements. These, after creation, insert this. Already I have explained this one. We'll be learning this at this time because we'll be learning trees and binary search trees here. And then coming to recursion and applications, when you are learning recursion and its application, we'll be learning tower of Ni problem, and then implementing GCD using three numbers, finding GCD using three numbers, and then at the end coming to graphs, we'll be implementing graph problem. And the last week, that is 13th week, April 28 to May 4, learning hashing, and so we'll be implementing the last program of the hashing. And now coming to the last one, and that is last week. Here we will be revising whatever we have studied for the previous 13 weeks, so that you are clear and you will be able to implement it in your lab. And that's all. The next videos we will be seeing how we will implement the programs, so that you have got some reference at the time of preparation. Okay, thank you.